Hello, good afternoon, everyone, or good evening, or good night, depending on where are you based. So we are ready to start this really nice session, and I hope you are enjoying the workshop as we do. And so far, we have had so many nice talks from everyone. So it's the bar is really high.
Yeah, that's the only thing I have to say. I like the workshop a lot, but this feedback thing is really missing. And normally you have people who are here and they're excited and something. And I love obviously all the emojis, but maybe put in the chat if you hate something or like something. Please make it as interactive as much as we can, so we get more an idea what people think. That would be great. Okay. And Diana has something to say. I'll hand over to her.
Hi, everyone. I wanted to share some good news that they are not news anymore because they happened last year, but I feel really compelled to talk about this. Last year in 2025, the software dartR was the winner of the Eureka Prize for Excellence in Research Software. It was super cool news because the Eureka Prizes are the most renowned awards given to scientists in Australia. So there is where really you can see some of the most amazing projects and most amazing research, and it's really, really inspiring. So I was very lucky to be able to attend the ceremony. As you can see, it was a very fancy affair. We all actually got showered and, some grooming, which we never do. But yeah, we joined the ceremony, and we didn't know when we attended. We didn't know. We knew that we were finalists. We didn't know who was going to win, and it was a bit like, the Oscars, that you get to know exactly right there when they read who the winner is. It was a surprise, kind of. We were hopeful, and yeah, we got the prize. And to tell you a bit about the backstage story, of course, we had to apply, so we nominated ourselves. That was a process that Luis and Bernd really led, and the rest of us contributed to. And I found that it was a very rewarding process to gather all the information and all of the stats of the impact that dartR has had. Yeah, it was really remarkable in how many fields and in how many countries dartR has been able to help research. Actually, I joined relatively recently, so in 2024, I joined this team, but they have been going on for years, and it made it really, really cool to see how it has grown and how much it has mattered in science. And in the same way that I just joined, you can join as well. If you have any functions or any ideas that you would like to implement, you can join us. They were very welcoming when I came up with the SexLinked functions, and it's been really, really cool. As part of the application process, we also needed to give some letters of recommendation. So we asked some people that were not direct collaborators, but that they could talk about the impact of dartR. And that was really, really cool to read these scientists just saying all the cool things and nice things about this software and how useful it has been in their lives and in their research. During the ceremony, we could barely believe that we won, and we all went to stage, and Bernd gave a speech, and it was all very cool. And really, Arthur, Luis, and Bernd have been kind of a leading force, and then more of us have joined. We got a bit of a prize, which was nice, and it's a prize that we got to reinvest into this workshop, and that we will keep reinvesting in helping you guys use the dartR software better and better. And just the last reminder that, as Bernd said in his speech during the ceremony, that we are a grassroots movement, right? It starts small, and then more people and more brains joined in. So it really goes from the user into the world. Yeah, and I'm just very happy to be part of this team, and congratulations to the leaders of this team.
Thanks a lot, Diana. That was very kind words and really nicely placed to ourselves. This whole session is probably a bragging session, how cool dartR is. So if you're not this kind of person, that just cut it out and look if there's a function you like, because that's what's mainly about. We will show some new developments, some new ideas, and mainly it is an invitation for every one of you. If you have something, a script, and Ethan will show you what the official way is, but please contact us if you think you have something that would be a valuable contribution in dartR, then please do so, because it's, as you can see, we kind of, okay, I mumble a little bit more. We were the first one when we put into the form for the Eureka-Prize to put in 13 people applying, because they didn't think that this kind of big groups are there. So we try to really grow even further to have the support of people, because there's so much to do and we just can't. So it would be really cool if some of you can contribute and help us to develop dartR further. And that's enough mumbling from me, and it's over to Luis.
Hi, everyone. Thank you, Diana, for those really nice words. And yes, and it has been a pleasure to work with Diana and all the other members. Everyone is so hardworking. Okay, so maybe we can start, and I can start sharing my screen. Can you see my screen? Yes? No? Hello? Can you confirm that you can see my screen?
Yes, we can. There are lots of, sorry, you can't see. There are lots of thumbs up.
Okay, sorry. Thank you. Okay, so as usual, or as in previous sessions, we start from here, from the POSIT cloud, and we start in the, this is the name of the space for today's session. We go and we start with copy a project. And then as you might remember, it takes a while, a little while, not too much. But anyway, and if you have questions, please feel to interrupt me. And if the other presenters can also let me know if there is a question. Here we go. So first, let's do what Bernd tell us to do at the beginning. If you remember, we go to global options to improve our panels so we can see better what we are doing. We go to global options, then we go to pane layout, and we put the console there. And then we say, okay. And then we have now the console to the right and the script into the left. Then we go to the int tutorials, session 9, and we open the RMD file, which is the R Markdown file that we are using for today. And then we open it. And we now do a little bit more of room. We maximize this one and maximize this one. Okay, so I was just testing the script, but there are some parts that are not truly working. So we are going to, we are going to jump between different versions. So we have the source, which is the code, what is actually rendered, and then the rendering of the code in Visual. And yeah, we need to wait a little bit for it to render. We use visual mode. Okay, and then a little bit more of room, we hide this one. Okay, so each one of these gray boxes, they are called chunks. So And then with this little green arrow, we are going to run all the chunk. Let's start with the first one. This is setting up the environment. And then we have our nice pictures. Then in the next chunk, we load the libraries. You know, when we load dartRverse, using library dartRverse, it will, all the different packages, the 7 packages of dartRverse are going to be loaded all at the same time. And we can see here, yeah, it also takes a couple of seconds. And so we have here that the versions of the packages and the 7 packages that are all already loaded. Okay, so this session is more about showing some hidden gems in dartR. Now we have over 200 different functions, and sometimes they are just hidden. And I think we are also working and thinking about putting something more visual, so to help the users. What are the different functions available, and grouping them by application. But hopefully that's going to be the next couple of weeks. So
very quickly, sorry, Luis.
Yes.
Because it's on the screen at the moment, you can see when you do load the library, you can see which versions you have loaded, 1.2.2. These are special curated versions for the workshops. They are not available on CRUN yet. So that's why we recommend at the moment use Posit Cloud. You can, I just give you that hint, get all the beta versions from the GitHub. These are all beta at the moment and will be hopefully CRUN soon. But at the moment, if you try to recreate some of the code we give you, you will not be able to run all of it because not all functions are on CRUN yet, which is the official repository you get when you install packages.
Okay, thank you, Bernd. So, and I like looking at nice things. So I like the plots are very have the same colors and are almost perfect on to the most small detail. And one of the most important details of plots is, of course, colors. And we have plenty of functions and things to do and how we can manage different colors. For example, we have the GL select colors. At this time, we are, instead of running the full chunk, we are going to run line by line. So, and remember, if you are in a Mac, you can do command return, and if you are on a PC, is control return. So let's run the first one. Then we have the select colors. This is the palette that is the default. When you run it, you will get this nice plot, which is not from dartR, but is from the package of that is generating colors. But anyway, here we have the nice colors and we have the codes for the colors. And then within this function, GL select colors, we have different palettes. And if we run the next one, we can see what is the different color palettes that are available in this library. And here, for example, this library is also very, very nice written because it tells us whether the palettes are colorblind friendly, and also what is the number of colors for each one of the palettes. And there are plenty of them. As you can see, there are 4 pages, and we have more options. For example, in this one, we have 115 different palettes, color palettes. And if that is not enough, also dartR has these different other palettes. And for example, if we want to use, let's use this library, GRHCL, which is one of these. And then one of these is the dark tree, which is this one. So if we want just to change any of these, we have just to change the name, copy paste the name of the palette and put it in palette. But for the moment, let's use dark tree. And the nice part of this function, I think this was developed by Arthur. So if you use inside of the function, you use the GenLight object, it will give you the number of colors. It will give you the same number of colors as there are populations in the GenLight object. So if we run this one, so it gives us 3 colors. No, 9 colors, I'm sorry, because possums has 9 populations, 10 populations. Okay, so here in call 2, we have 10 different colors. And if you want, you are hungry a little bit more of colorful things, I have found very useful this website from Adobe. It's the color wheel, and it's very helpful because you can choose different palettes, for example, and you can move them around, and you can just copy the color code and paste it in the function. And also another interesting feature of this website is you go to accessibility tools, and then you go to the colorblind safe. It will tell you first whether it's colorblind safe with a green tick, and also it will show you how the different persons with different types of color blindness, how they see the different colors. So it's a nice way to find nice colors. Okay, and so usually it's very important to use if you are doing a different analysis. It's important to use the same color for each one of the populations across all the plots. So, for example, here you have to look for this parameter. In most of the plotting functions of dartR, you will find this parameter, and we have just to use the colors we selected with GL select colors. For example, this function GL report diversity give us the different diversity indices that Bill was talking about in his talk. And then we have GL report heterozygosity. We have the observed heterozygosity, expected heterozygosity, and FIS. And in both plots, we are having the same colors for the populations. So that's a nice thing that you can do with all the plots. Just find this parameter. So, and here is where we have to change to source, because doesn't work. Nope. So let's go to source. Okay, so we have been here, and let's start here. So we have the possums dataset. And so the idea of this small piece of the presentation is showing you that you can customize your plot almost without limits. For example, let's use the possums GL. And then we run just a PCA. And here you can see these 2 important parameters. Plot dir is where we are going to save the plot. And then we have the plot file, which is the name of the plot. So let's run it. Okay, you have seen this plot many times during the workshop. So now this plot has been saved into the working directory, as we said here. And then after we saved it, we are going to upload to read it again with read RDS. And we got it again here. So P1 has the plot, as you can see. So now that we have the plot here, we can do any customization, almost infinite number of ways to customize the plot. In this case, let's just remove the axis labels and the ticks, and let's remove the legends and use a simple DM. In this case, we are going to use the DMBW. And then when we run it, we can see that all these customizations are so easy to include in the plot. And as you will see that in the program, there is a link for this resource, which is the GG manual, and there are literally hundreds of pages about how you can customize the plot. Okay, so we can go to the next one. For example, this also is the interactive version. When you want to see exactly what is an individual that is an outlier, we would use the interactive true, for example. And then if we hover over each of the points of the dots, and each dot is one individual, we can see the individual name and the population name. And for example, if we, let's see, this individual looks kind of weird. It's right here in the middle. It's number 42. And then you can go and investigate a little bit more what is weird about individual number 42. And then other nice things is that you can also zoom and zoom a little bit more. And then you go to home to start from the beginning. Then we also the nice 3D plot, which is very useful when you have three axes that are informative. And the other part is you can move the plot around. You can zoom in and zoom out. You can even delete or hide the populations. Let's hide the A, for example. And it hides. And then, for example, if you want just the A, you click 2 times, and you have just the A. And also, you can also save this plot as an HTML file. Okay, let's go to our next example. Let's run the clustering method SNMF just very quickly. This doesn't take a lot. Just 4 repetitions with 3 K3. And then we plot it here. We have here a bit, some nice parameters. For example, we are not saving the plot this time. You know that you can do it. We can, it's very nice, this function, because we can order the bar plot using a dendrogram, which in most of the datasets gives you very insightful visualizations. Let's run this one. So we have, instead of ordering the individuals by population by label or whatever other metric, we are using a dendrogram. And then we have the branches are the colors for the populations. So here is very clear, right? That there are 3 populations, and the clusters align with the dendrogram. But in other datasets that are more maybe larger datasets, you will see very interesting patterns when you use the dendrogram to order the bar plots. And then the other very important, I think, visualization or exploratory tool is the smear plot. So, for example, let's go here. Let's make smaller our dataset by filtering the call rate using a threshold of 1 and removing the monomorphs. Then we run in the same way we can use a dendrogram to order the smear plot. And here, and again, maybe with more divergent populations, you can see more interesting patterns. And here, if you haven't used this function before, there are 3 different colors. In this case, I use these colors, but you can use any combination of colors. So here, the base color is the homozygote, the pink is the heterozygote, and the blue one is the homozygote for the alternative allele. Okay, and the other thing that I have found very informative is to actually ordering the loci by FST. We first run FST in each one of the individually for each one of the locus. Then we order by decreasing values, and then we plot the smear plot. And you can see that it makes sense that the loci with higher FST values are the more diverse, with more heterozygotes. The FST and loci with lower FST are more homozygous. And then also here, the other interesting part of a smear plot is one dataset that we don't usually, or I haven't seen using many users, this dataset, which is the SilicoDart. The SilicoDart is a very important dataset that has not been used as it should be, whereas the SilicoDart is a data that is presence and absence. So if you have in the sequencing, when Dart sequences your data, you will receive 2 different reports, the SNP data and the SilicoDart data. And the SilicoDart data is where, for example, when the restriction enzymes, they have a mutation in the binding site, the restriction enzyme is not going to bind into the DNA, so it's not going to amplify, and that's an absence. And this information is actually very important, very useful, and very valuable when you have different, if you have subspecies in the same data set or populations that are very divergent. Okay, and we can also plot the SilicoDart. That is not working because we forget this part. Okay, so here this is I think it's turtles from Arthur, and when we use the dendrogram, we can see here very clearly patterns that are different and coincide with the dendrogram in the smear plot. Okay. And then in the same way, we can use, in this case, we can use the polymorphism information content to order the different, to order the silico dart loci. And then also is a nice visualization about how the different patterns in the smear plot coincide with the dendrogram, and how the more polymorphic sites are to the left. And then you can see here to the right that almost in all the individuals, just enough, almost there is an absence of in this loci. Okay, and I think yeah, the same way we can use the smear plot and ordering by populations. And again, here is not a big differentiation between the populations because they are very close from each other. And here, for example, this is also using the Bandicoot dataset. We can see that in this last branch of the dendrogram, we have a lot of missing data, which might be because these individuals are very divergent, and the restriction enzyme did not bind to the DNA. So there are a lot of missing data. Okay, now I think Bernd talking about how we have.
Yeah, sorry.
Yes.
There were some questions. Sorry, I was occupied by something else. Sorry, I didn't see that. How come the pattern maybe put on stage?
How come the pattern is different in the last plot, I guess?
Yeah, I guess. Yeah.
Okay. Yes. No, definitely. The kinship, for kinship, you use SNP data, and silico dart SNP data is biallelic. So we have 3 different combinations: heterozygotes, homozygote for the alternative allele, and homozygote for the reference allele. And for silico dart, we have just 2 different types. We have absent and presence. So we cannot use silico dart for kinship. But we have in dartR, we have plenty of functions that work with silico dart.
Okay. And there were, what is another one? Let's go through them here.
No, it's not running the smear plot using the dendrogram, but it's very easy. If you want to install the developing version, I can also show you how to do it. Maybe, for example, I don't remember the name of exactly the name, but you can do, for example, you go DevTools, colon or semicolon, and then install GitHub add. Oh no, sorry. Then you paste this part of the GitHub repository, and then use add, and then you can, for example, install the developing version, which is going to have sometimes when the users identify some box in the BOGS in the functions, we usually take a couple of days to fix it, and then we make it available in the developing version. And then we tell the users to install the developing version, and then the bug is fixed. And you can install any, for example, if you want to use dartR.popgen, the same, and you will be able to access all these latest features whenever you want. Mm-hmm.
Yes. Sorry, I'm confused. My setup got distracted.
We have the GL join, where you can join different orders, and you can put it together. At the moment, if you accept the function just accepts 2 GenLite objects. So you, for example, you go first, you have a GenLite object, let's say GL join. Your first GenLite object is T1, and your second GenLite is T2, for example, and then you assign this to a variable T3, for example. And then if you have more than 2, you would use T3, T4, something like that. And you join one by one. I think hopefully that makes sense. Okay.
The question's coming in. I'm not sure. Here's one.
Yeah. Okay. Yeah. So you have your GenLite object, right? Let's say Platypus GL, right? And we have you want to assign it. You want to add individual metrics. You have your all your metadata in a CSV file. You need to put in the first column. No, it doesn't matter actually the column number, but in one column should have the name ID, which should correspond with your Dart report, and that's it. But you can add any other information, including sex, latitude, longitude, different population assignments, whatever information you have from the field, or whether other source information, and then you can do GL add individual metrics and say platypus, and then individual meta file, and then you put here, for example, let's say your CSV file is test CSV, and then you run the function, and all the individual metrics are going to be added to the GenLite object. Mm-hmm. Okay. Okay, yeah, that's a good question. You don't need just the name of the file. The extension is going to be added automatically, which under the extension is RDS. Is how the R objects are saved, or the easiest way. Mm-hmm. Okay, I guess there is no more questions. I guess not.
No? Shall I go on, or you wanna?
Maybe
Now you have more, don't you?
Maybe because I think we are running out of time. Maybe we can. I can respond it at the end in the chat.
Okay.
Yeah. Okay. Okay. So we have the BLAST. Perhaps you have heard about BLAST. It's an algorithm that is very, very efficient because it has to look for sequences across the across the hundreds of thousands of megabytes of the reference genome. So it's a very nice tool that has been very used very widely, and as is such a useful tool that we have a beautiful function that you can run BLAST in your JLite object, and it just works. I mean, it works just with Dart data, because Dart data gives you the trim sequence of the SNP. So with that information, that sequence, we can BLAST each one of the sequences of each locus. We can BLAST it to any reference genome the times we want it, and very quickly. So first you have to download the BLAST BLAST binary. Here I put the website here, and there are different tasks that you can in which you can use BLAST. For example, the most popular is this one, which is for small sequences. But for example, there are a lot of different applications in which you can use BLAST. For example, if you want to to BLAST your SNPs to a different genome that is not closer. The word for the not closer is the farther away of your species, and you want to look for similar sequence, you would use the DCA MegaBLAST. Okay, so there are many different applications and a lot of different parameters, and for use, you can also of course use BLAST online. But if you have, for example, thousands of or maybe tens of thousands of SNPs, you cannot upload it to the website. Okay, so for running BLAST, you have first to create a FASTA file, then you have to prepare and run and generate a database, then running BLAST, then you have to do the filtering of all the hits. So it's a lot of different steps that are not that easy to follow. But with this nice function, the GLBLAST, you do it all at once. And then if you go here, for example, the results of BLAST are stored in the metadata, in the locus metadata, which is the last columns. All these columns are the results of the BLAST. So even if Dart BLAST your sequences, you can perhaps there is a new reference genome that you want to BLAST. You can do it very, very quickly with this function. And then once that you have this information from a reference genome, you have a wide many more analysis and things that you can do. And even if you don't have a reference genome for your species, it's usually very useful and very valuable to use the closest reference genome to your species. So here we have this. We have to assign first to use this information of the reference genome. We have to assign the SNP position to this slot. In this specific dataset of the platypus is in this position, and then we assign the chromosome. And then we show the first chromosomes. For example, you can see here the different chromosomes. Then we can access, for example, this nice function, which is the glplot SNP density, which gives us the density of the SNPs in each one of the chromosomes. And you can, for example, change the size of the bin, the minimum number of SNPs you want for each chromosome, and there are different very nice palettes. And also here is not very obvious the pattern, but because there are just 1,000 SNPs. But when you have a full data set, it looks very nice. And you can see how the centromeres and the telomeres, how they changed in the density, which is very nice. Okay, then we can all...
Yes? Just very quickly, this is also the information you need when you want to have bubbles correction on different chromosomes. You know, that's how you get the information.
Mm-hmm. Yeah, I think I'm going to stop here because I'm out of my time. But there are more different examples in the tutorial with how you can use GFF files, and we have these different functions to find what are the genes for that you, for example, you identify using approaches to detect loci under selection, how to find if a specific genes are in your SNPs. And yes, and you can go through this tutorial when you have time. Yeah, thank you.
Yeah, yeah. Mm-hmm. I'll go through some of the commands, but please be aware these are all also on the website and also in the script tutorial 9. You can find them. And yes, there's some gems I have to learn sometimes because Louis sneaks some bits in which I'm not aware of, and vice versa. Probably he doesn't know what I do. So I share my screen quickly and try to get into it and try to give you some cool function. This is, yeah. This is the, probably most of you know this GL map interactive. Yeah. Can you please do a thumbs up if you know about that? And obviously this is cool because you can basically nicely easy visualize something. What some people probably don't know, you know, this, you can actually, for example, change the background of the thing. There's something called provider as an argument, and so you can say, please use a different provider. Just will take a while because my internet is slow. But you can see now I have a watercolor background. You know, I'm not saying this is a good idea, but you can see you can change the background of the thing. And if you ask, hey, how many are there? There are actually lots of them. If you want to have different providers, you can go to the website, which is on the help page of the map interactive function. And as you can see, there are hundreds of different backgrounds you can use for different colors and schemes and so on. So you can customize the background of this color. Not sure if that helps for publication, but maybe for a presentation somewhere along the way. Okay. Then this function is actually just to, because I'm so happy to mumble a little bit along, this is a function that is actually I have written at a workshop, probably in the first workshop ever I did with Arthur together as a museum, Sydney, Australian museum in Sydney. We were invited to present dartR, and it was really, yeah, in the infancy. And there we, I created this GL map function because someone said, it wouldn't be cool to see that on a map. Just to let people know, to do that, you have obviously your GL genlight object, and when you run it, there needs to be something, another let long, and this needs to be in unprotected coordinates, but normally in WGS84, yeah, and then it creates it, then puts it on the right position of the map. Okay, there is one more thing, because initially it actually was even used for publication. We had basically tried to visualize gene flow, and this is based on private alleles, and this was on possums, and we basically could show, okay, individuals kind of, they don't like them in middle zone, they go outside of them. So you basically can visualize this using the background map as well, any kind of distance matrix or anything, and probably most people don't know. So what you can do is, I calculate, I run GL report PA. You could also do a GL report FST per pop or something, basically any sort of distance matrix. And in the end, when you run that, you get something like that. I have 4 populations, A, B, C, D. I just do a subset. And then this is the numbers of private alleles going from population A to B and from B to A. So it's asymmetric. Yeah. And I'm not saying this is a nice plot, but you can put this matrix also on a plot. And that's using this function. So you say GL map interactive, put your gendered object there, and then you say matrix. And if it's non-symmetric, you can basically put it on there, and you can see it visualizes the numbers basically there. And not saying this is really good, but you can maybe see, okay, they're more likely to go from here to there, from there to there. So any kind of distance matrix you want to put in a spatial layout, you can try and use the GL map interactive function. This is obviously not for publication, but maybe for exploratory, understand your data and this kind of things. Cool? Okay. I have one more thing which is a bit longer, and this is, I'm not sure how much you want to go into it. Basically, what happens in the background, we were struggling, and probably you were struggling, and I know Florian was. If you have a PCA and you have, say, 50,000 SNPs and 300 individuals, a PCA at the moment when you run it takes in dartR probably an hour, 2 hours. And if you have more than 1 million SNPs, it probably crashes. So dartR is not future-proof in that sense at the moment, or was, hopefully, because it was not handling really big data set well. And that has to do with this beautiful GenLine object. Just you saw that. This is a so-called GenLine object. Yeah, it's confusing. We developed it further. It's called now a dartR object, but the main bit is here. It scores the genetic data in a certain sense, which is super cool because it's compact. So it kind of compresses your data set, but it comes at a cost. If you do something like S matrix, it has to decompress the whole thing from a bit storage into another one. And that actually takes a bit of time. And all the computations take long. And if you have a big data set, that can take minutes. Yeah. So we needed a better way to storage it. And the thing we came up with is a so-called big data matrix. And in the new versions, there will be, it's still in a testing phase, we convert a GenLine object to a so-called FBM object. So the only thing you need to do is this. And then it converts it. You don't see anything. If you look now at the new object, it's still a dartR object, but it has an FBM component. And the gen component is empty, meaning it converted internally how it stores the data. And you think, yeah, okay, well, great. Why? Both formats have really advantages. As I say, the normal GenLine object is really good for saving data, storing it, because it's very compact. It makes your big object small, but it's really bad for computation if you have lots of things to do. And I hopefully can say that there's actually a function also where you can convert it backwards. Sorry. You can basically convert your FBM object to a gen object. There's another version. You can back and forth. And so the idea is you load it, convert it, do some computation, convert it back, and save it again. In future, hopefully, the save option will do that automatically. So this is brand new hot press, and I show you hopefully why this is a good idea. I create now, if this works, two objects. They're the same as simulated data. It really doesn't matter what it is. There is GL large, and actually it's not super large because I want to make it palatable for this tutorial. So this is the normal object, and there's the GL large FBM object, which is the more efficient one. You can see the normal object has the gen component, and the other one has the FBM component. Yeah. And now we do this thing. We do a PCA on the normal one, and this is obviously still really small. I think it should take 7 seconds. And then it's done, maybe. Okay, 8 seconds. And here is the same one now as the FVM object. And if live works, it should be far faster. Yeah. And that doesn't seem to be impressive, but this is the advantage is much, much bigger if you have a really big object. So if someone takes now 10 minutes, and you can happy for you to try, and you use the other version, it takes really seconds. I calculated a PCA on 500,000 SNPs and 1,000 individuals within 5 minutes. So it depends obviously on the computer, but it's really fast.
You can show the disk size, like in the objects.
I
like that too.
But this is cheating. Maybe I should say that. This is basically the whole object. What the FBM object actually does. Chris was referring to the size here. You think this is much smaller? It's not. It's basically what it does. It stores the whole data on the disk and not in the memory, which is really cool because you normally have ample of disk space, but your memory is slow. But it is really fast at copying the space, the things from the disk into the active memory. It does a memory mapping, which is super fast. And if you have a SD RAM thingy thing, it's mind-blowing fast. Yeah. So this is not the real story.
Okay.
It's actually bigger. Yeah, good catch. So yeah, so believe me, it is actually really much faster, 5 to 50. Depends really on the size. And it can handle, that's the good news. If you have, quite often you filter a GenLight object 7 times, and the old version would have had it in your memory, and you clunk up your memory afterward. The new version, it is on disk, and you can't really clunk up your disk. The only thing, when you save it, please make sure you convert it back into a GenLight object and then save it. Yeah. And feel free, if you have the latest version of dartR, to use it, but please don't hate me if it still crashes. We are still implementing it, but I think it's the future. And the very last one I want to show, because it's also an old function which nobody uses, and I think it's really unfair. It's GL print history. Quite often you run a certain amount of filters. Yeah. And you forgot actually which of the 17 filters do I have applied to this object. And that took a long time, and it's annoying. And there is your answer. You run this beautiful function. And this tells you what has happened to your object. So basically, for every of the objects, normally we track the history. So you use this file to create this. This one, you filtered it by 0.95, and then you did that and that. So basically, all the filters you apply to an object are stored somewhere in the history, and you can recreate what happened to your object. There was actually a function GL play history, so you could have used another object and do the exact same filter steps on that one. But I think Arthur was the one who kind of kicked it out somewhere at some stage. I have to find it again. And that's for me, I think. Yep. And I hand over now to Ethan, if there are not any questions.
Cool. All right. Hi, guys. So I'm just going to run through some of the basic things that's expected when writing functions in dartR. And then I'll also just go through a quick tutorial of how to fork a repository, pull it to your local machine, do the changes, push that back to Git, and then do a pull request back to that repository. So I'll just share my screen. All right, can you guys see that?
Yeah.
So first things first, there's a basic sort of structure we expect when writing a dartR function. So there's quite a bit here, obviously 15 points, but I'll just run through some of the most basic things, basically. These are things you have to have when you're writing a new function in dartR. So the first things first is this Roxygen2 documentation. So all R packages use Roxygen2 to document all functions that we write. And one of the things they do is whenever you do a help query in R, this is the information that comes up and is generated by that function. The first thing we start with is the name of the name of the function, the title, sort of a brief description of what it is your function actually does. And then you've got the parameters here. So the parameters are the inputs like this for your function. So the most important thing is to have the name of the parameters, obviously, a brief description of what they do, and then you can also include the type you expect from people. So character string, or a Boolean, or integer, whatever it might be. Then you have some details here, just a brief description of what the function actually does. And then you can also have an example here. So the next thing is defining the function. So this is an example of a header of, now this function already exists in dartR.base, I believe. But this is an example where we have GL filter. It's a function we define. We have the input X, the method, threshold, whether to function out, whether to remove monomorphs, recalculate, recursive, whether to plot, the number of bins, and a verbosity. So the main thing when setting the inputs for your function is to make sure the names are fairly descriptive. They don't have to be perfect, obviously, but it's important that people looking at them can understand roughly what it is that that parameter actually means based just on its name alone. The other thing is setting the verbosity. So you can set base verbosity for each of your functions down here. But basically what verbosity does is it controls the output of that function as it runs. So as you can see, 0, it'll only show silent or fatal errors. It's good for sort of batch processing, doing large function runs. 1, it will tell you this, that the function started and it's finished and show fatal errors. 2, it will also notify warnings and a progress log. 3, reports progress and results summary. And 4, it's basically what's been run, but then also what will be run. And then 5, it displays a full report of everything that's being run. So when you're in an R studio session, if you're writing your functions, you can either set the verbosity like this, or you can set it globally for that whole session with the GL set verbosity function. The next thing you do when writing your functions is to include these checks of the actual parameters or the inputs that you've defined above here. So the main thing we're checking for here is we're actually checking that the inputs that are being supplied are as expected. So the main thing to ensure here is that if someone provides an incorrect input, that any errors that are thrown are defined explicitly by the function, and people don't get confused. So here, for instance, if someone doesn't have a certain package installed, instead of R throwing some weird esoteric function error that people might not understand, your function has a very clear error message which just said, this package, insert package, Heidi Weinberg has not been installed and you need to install it now. That just makes it really easy for people if they happen to have a wrong function input type. The other thing is basic flag. So this is just basically flagging that this is in fact the start of your script, and then having these util flag starts. That basically just flags that this is the start of your script and everything from here on out is the actual function running. The other thing to include is a do the job. So basically everything below the do the job tag is the actual function running in its entirety, if you will. So this is just a very basic example here called thingy, not very creative, but this is just the checking that the inputs are as expected. And then do the job is just the output as it actually, so the do the job, everything below it is the function actually running. In this case, adding up our 2 inputs and then returning the output. The final thing then is the displaying output. So we expect that all plots to be displayed by dartR functions are done using the ggplot2 function. So this is an example here of defining a ggplot object, setting its values, and then if you were to return it as a function call, you would return that object. And then when that object is called, it displays that ggplot. The other thing is there's a rough, just having some style. So the main thing to note here is commenting. Don't comment too much, but comment enough and generously enough that people can read it and get a general gist of what your code's doing just at a first glance. The other thing is indentation. Code isn't indented properly, can be quite hard to read and can be very hard to sort of understand the flow. But for a full rundown of basic R style programming, there's this great guide here by Hadley Wickham. It's just called the Advanced R Guide, and you can just look it up. It's got the style guide. So now that I've sort of run through the basics of writing a function in R, we will then go through the basics of actually writing our function, pushing it to a fork, and then doing a pull request. So obviously this all here is just sort of a reference for you guys coming back to it, but I'll do an actual example now. So I've got our example here, which is the gl.document function. So basically what this does is this just generates this empty Roxygen documentation at the very start of any function calls. So as you can see, it's got all the elements that I was talking about. It's got a good function name. Sorry, it's got good input names that people can understand when they look at them first. It's got example calls, for instance. It's got ensuring that the actual inputs are as expected. It's got plenty of commentations so people actually know what it is that's going on. And then it's got here, so it's closing the output and making sure that that function actually returns something. So first things first, so let's say, for instance, in this case, we're going to add this function to our dartR.base repo. So the first thing we'll do is we'll go to dartR.base. So this is a repo in which we're going to add that function. So the first thing we'll do here then is we'll just go fork. As you see, I've already created a fork, but we can just create a new fork. And then in this case, it'll be owned. Oh, so a fork already exists. I'll just she will choose a different repo quickly. Maybe we'll do.
Yeah, just to let people know, this is for people really who want to be involved in helping developing dartR. You know, you don't have to do the whole thing. You can also send a script, but if you really wanna, then you do that exactly what Ethan is about to demonstrate. Go to some of the packages, they're all on GitHub. You create a fork, which is basically a copy. Then you test your function and do anything with it, and then you can do something which we will show now, which is a pull request. Basically make us aware there's something you think this is really good, you follow the guidelines, and then we integrate the function and make you a contributor.
Yeah, basically what Bernd said. Thank you.
Sorry.
So in this case, we'll do our dartR.spatial because I haven't had a fork to it. So we'll go fork, create new fork. And so in this case, you're the owner, and we'll name it something, dartR.spatial.tutorial. Just same description, whatever it is. And then the main thing here is the branch. So we don't want to be copying just the main branch because we'll be pushing to the dev branch, which is the branch you push everything to, and then Bernd or Luis or someone else will then review those changes and then push it to the main branch. So we'll untick that. We'll go create fork. It's just creating it for us now. Might take a while depending on the size of the repo. Here we go. So it's done. Yep, as you can see, forked from greenstripe.gecko.rspatial. Now, to actually pull this down into our home RStudio, we'll just go code. We'll copy this HTTPS link here. Go to our RStudio, go new project. Actually, hold on, I have to share. I'll just change to 8. Yeah. So now we're in our R Studio. We'll just go File, New Project, Version Control, Git, repository URL. Yep. dartR.spatial testing. We'll just do it on our desktop. Create project. So it now pulls all that down into it. Here we go, pulling all those objects. Yep. Might take a while.
As you can see, already populates all the functions which are there.
Yep.
And then
So then we'll go to Git. As you can see, we're in the main. So if you haven't already become a sort of a working member of one of these, and you won't have your own dev branch, so we'll just go up here to create new branch. We'll call it dev Ethan, and you can call it dev whatever your name is. Creates a new branch. Just, yep. There we are. So we're now in dev Ethan. You can go pull just to make sure we pull any changes already up to date. Yep, all good. Now we can go to R, and now we can create our new gl.document function. So here we go. Paste in that code. You can then save it as gl.document. All good. We can then restart our session. Just do a quick build check just to make sure that everything works and installs. There we go, all good. So dartR.spatial is installed, which means that added function has worked well, hasn't thrown any errors. Yep, dartR.spatial, cool, perfect. So then we'll just go back to Git, and here's our addition, which is gl.document. We can go click on that, go commit, just add a nice commit message. So added gl.document.r. You can go commit, just, yep, add that, close that, and go push. So this is just pushing it back to our fork of this repo. Done. As you can see, it's done because it's now been pushed back. We can then go home and go back to GitHub. Sorry? Yeah, I'm just, there we go. And sorry, we'll just go back to GitHub. There we are. Yep, as you can see, so dev Ethan had recent pushes 3 seconds ago. We'll go compare and pull request. So we'll be sure to merge from, here we go. So this is, yep, there it is. So we're pushing from main. We're pushing to main from dev Ethan, added GL document. I will say added. Yep, create pull request. It's just working now. Make sure it can merge automatically. Might take a while, but come on. There we go. Go merge pull request. Yep. Confirm merge. Cool. So dev branch can be, we can delete that branch, but we'll leave that for now. So we'll just go back to dartR.spatial.tutorial.
So it's basically the whole workflow. If you develop the function, push it back to your fork, and then give it back to me or Luis or whoever is the responsible person for the repository.
Here we go. R. So yep, if you see an R, we can see it's 2 minutes ago added GL document.R, and that's our function. Now the final step is we can contribute, so we can merge this fork back to the base repo. So in this case, we'll go dartR.spatial, yep. We'll go dev, and then we'll try and merge our dev branch. All right, yep. We'll try and move our dev branch to the original dev branch. Oh no, sorry, main rather. Yep, so it can be merged automatically. We'll say added GL dot document. So now now we just have to wait for Bernd or Luis to verify it. But yeah, that's it basically. So that's if you're trying to add a function and then pull a pull, that's basically the entire workflow. But obviously quite convoluted can be. So if you guys can just refer back to this to that first document if you want. But yeah, that's basically it, guys. Thanks.
Thank you, Ethan.
Can I just add something?
Yes, Doctor. Go.
Yeah. So we're really keen for dartR to be a community thing where there's a lot of people contributing. And one of the really important ways you can contribute is if you generate a script that does a particular function, then what Ethan's just shown you is how you can formally submit that to dartR for consideration, and then subsequently keep your maintenance role on that script. So you submit the script, it goes into dartR, and then because you've got this pull cycle, pulling it down to forking it down, and then putting a pull request in to make it go back up, you can keep maintaining your own script over time, so you can become part of the community. And so I know lots of people have got scripts out there that they've generated for their own work that could be of broad interest. So we'd love to see them. And this is a way of doing it and keeping in touch with your own script and being able to improve it and modify it over time.
Yes, thank you, Arthur. And I guess other important thing is that also if you want to join sometime in the future to be a dartR developer, we have every weekly meetings every Wednesday, 1:30. So that could be also another of the commitments. And I guess another important piece of information is, maybe I can share my screen very quickly, is that our main point of contact is our Google forum, our Google Groups forum, which is here. And I posted the link in the resources if you want to read it. And then here you can go here and you can ask any questions that you want. And we usually take maybe 1 day or two to respond all the questions. And as you can see now, we have more than 600 messages and 381 members group. So if you have ever a question or something that you need to know, probably you are going to find it in this forum. And you have just to use this help box here and for example, look for any term, and you will find the different different posts about that topic, for example, here. and yeah, and maybe you can do a better search using a different combination of words to get a very query. Yeah, thank you. That's all what I wanted to show.
I think again with that, we'd like to see people answering each other's questions, not just it being a resource where you put a question up and then expect us to answer it. Well, we will, of course, and Luis has been very active with that, but you should be able to put a question up there, and other people should feel confident enough to answer it within the community without it necessarily coming to us. So feel free to do that.
Yeah, sorry, I have one thing that's kind of important for me to say, because there was this question, and at what stage are you guys in the development of dartRverse package, and how long until it's ready for CRUN? There, just to make that clear, there is already dartRverse on CRUN, and some people still use dartR, their old legacy package, and I recommend not doing that. Just delete it and use the dartRverse package, because we're no longer developing. I know it's weird. dartR, the package on CRUN, you know, it has been frozen. We basically are now in the dartRverse. Has lots of reasons. The main reason, CRUN doesn't like huge packages, and ours was just too big, so we had to break it in smaller ones. In the best of the world, you don't see a difference. You do library dartRverse, it loads all the packages, and everything is fine. Yeah. But please use dartRverse when you say library dartRverse and not dartR, because dartR, I don't think there are many mistakes, but definitely you don't get the latest functions in there. Yeah. So please use the latest dartRverse.
Yeah. And Bernd, did you
one more thing?
Did you describe the difference between dev, beta, and CRAN?
I was about to say that. Thanks.
Okay. Sorry.
There are different branches, they're called, on GitHub. There is main, beta, and dev, and then even some dev Bernd, dev Luis, but you don't care about that normally. The main one is, except for really, really minor bug fixes, exactly the thing that what is on CRUN, and that has been validated and has been run, and it should not break. Yeah, obviously there could be still errors in there. Please be patient. You know, that's like every software. Then there's a beta branch, which is the one which is almost like CRUN, but basically where all the developed stuff comes in. We test it. It's in the dev branch. It's really dangerous to use it because it may break your system. So only do that if you really know what you're doing. And then we merge it into into beta, and submit it to CRUN. Once it's accepted to CRUN, everything that was beta becomes the main. So from your security point of view, use the CRUN version. If you need a feature that's actually really important, use the dev version on your own risk. And beta is basically an intermediate step where we try to consolidate the dev version. So sometimes beta is useful, but in 97%, it's only useful for us when we consolidate some functions. Does that make sense? I hope so.
Yeah.
Okay, I guess we are early today. And I think Arthur is going to be in a table at 4 o'clock.
Yeah. I think it was 4:30, I think. Was it
4:30?
Yeah. Give people an hour break. Yeah. But just maybe I could just say one other thing in terms of the development of this. There's a number of things on the boil. One is integrating dartRverse with OneDart, and we're trying to get an interface going between those two so that people who are using OneDart to do certain things have a clear and transparent passage between that and dartRverse. Another thing, as Bernd alluded to, is handling big data, and that's obviously something really important, and he's gone through that. And then further integration with genomics is really important because genomes are now spewing out at a great rate of knots, and so there's lots of things we might be able to do with genomics that we couldn't do before. And obviously, Luis is showing great examples of how you can map the SNPs up and find out where they are on the scaffolds. You know, they're not really chromosomes; they're actually scaffolds that it's mapping them onto. And that's really that's going to be an area of development for sure. And then the next one is the AI. And I don't know if people have started playing with AI like Claude Code. You know, in terms of writing your scripts. So if you wanted to write a script along the lines of what Ethan talked about, or you've got a script you want to convert it, you can just hand it one of our scripts and say you want it to be changed like this, and you know, Claude will just do that for you, and so will ChatGPT. This is revolutionary, but the real revolution for me, I think we're going to hear about in a session coming up, is the fact that Claude Code will now not only generate scripts and bash scripts and things like that for you, but it'll actually run them and then take the results and use R to produce graphs and then hand it all back to you. And so this is revolutionary. And in a sense, it's a bit of a challenge for us to make sure that we stay relevant in that new environment. And so that's another challenge that we're going to be facing. So, but we're up for the task. We're all very keen, and we're very keen to see more developers come online so that we can really make this grow along the lines of things like, you know, MySQL and Linux. You know, where you've got this massive community of people that are donating their time and building capacity for the community. So active developer environment and bringing more people in is another challenge. So they're all the things that we're hoping will happen with this, and then we can, and once that happens a bit, we can get another Eureka Prize, right? That's the plan. So anyway, that's I just want to add that at the end, I guess. And sorry.